in this lecture, we are going to use integral to find the region, the area of a region. So look at the area of this region S. So what we have is that on the most left, you have a vertical line, x equals a. On the most right, you have this vertical line, x equals b. So x is between a and b. Okay, then above it, you have the red curve, y equals f of x. And on the bottom, you have the blue curve, y equals g of x. So these four pieces of curve together close region S in the middle. And we're going to find out the area of this part. How are we going to do it? So you can imagine this region S is built up with a lot of very thin vertical stripes. Then for each of the vertical stripe, which we have here, okay, you can imagine it has pretty much the same, pretty much you can imagine it as a rectangle. So we are having a Riemann sum. So the area is chopped into a lot of very thin stripes, and then the area will just be the integral of the area of each stripe, which will be the top and the bottom minus the bottom for the y coordinate. Okay, so the length here is pretty much f minus g at x star, and then the width will be delta x. So when you add all these stripes together, you get a Riemann sum, which is the integral from the lower bound of x, a, to the upper bound of x, b. Then the function that you put in integral is f of x minus g of x. And of course, that is equal to the difference of the integrals. Okay, the integral of a difference is the difference of the two integrals. And that is pretty much how we are going to compute it. And here we put it as a theorem. The region that is bounded by f of x and g of x, and then x equals a and b, is the integral from the lower bound of x to the upper bound of x, a to b. Then for the y coordinate, you take the difference, f of x minus g of x. And here we have a little remark. Again, the integral of a difference is the difference of the integral. Okay. Let's see some examples. The first one, well, we are looking for the area of the region bounded by these functions. So of course, the first thing will be get this region or draw all these curves. So, well, x equals 0 is the y-axis. X equals 1, I guess I'll go somewhere here. X equals 1. Y equals x, that is a linear equation or a straight line with, y equals x is y equals 1x plus 0. So it passes through the origin as the y-slope with the slope 1, rising with the slope 1. And it will meet the x equals 0 at the origin and meet x equals 1 at, when x equals 1, y equals x also equals 1. So this is my y equals x. Finally, x squared, y equals x squared plus 1. this is a parabola. When x equals 0, y equals 1. So it's here, and then parabola open upward. And I need to draw it a little bit upper, because when x equals 1, y equals x squared plus 1, and when x equals 1, it will be 1 squared plus 1, that's 2. Right? So it means the curve y equals x squared plus 1 at 1, 2. And this is the origin. Although I don't really need to know all these points, some of them you might need it so that you know how the graphs meet each other. Most of them you don't really need to work them out. Okay, and of course the shaded region that we're looking at is this part. Then how are we going to compute it? Well, you are in the xy plane, so pretty much you only have two choices. Either you use x as independent variable or use y as independent variable. How are you going to decide which one you are going to use? So if you are able to tell the lower and upper bound of all the vertical segments, you chop it into teeny tiny vertical lines. If you know where the top and the bottoms are in terms of the x coordinate, that's what you want. Okay, also you would want to the variable itself, the region itself was bounded strictly between a certain x, two parallel numbers, well, two parallel lines, or two tips. So that's why we are going to use x as independent variable, because we know that x sits between 0 and 1. And meanwhile, on each stripe, you know f of x. That's my f of x, and that's my g of x. Okay? It won't work if you use the horizontals, because, well, maybe you can, but it will be a lot of work, because when you pick y, what is this x coordinate? You don't know. It will be a lot of work. I think it's doable, but when you chop it, let me pick another color, use black. Now, when you are doing horizontal line, this is between x squared plus 1 and x equals 1, but later you are going to be between, actually these are connected. Later you are going to, the horizontal line segment will be between x equals 0 and x equals 1. X equals y equals x. See, so actually the upper and lower bound are not consistent. So again, it's doable, but a lot of more work. So we are going to use x as independent variable. And pretty much when you pick an x, you are computing these sort of teeny tiny strips, and then you add them up. So the formula says the area equals the lower limit. Our x is between 0 and 1. So lower limit to upper limit then is the function that is above, y equals f of x, which will be x squared plus 1, minus the function on the bottom, that's y equals x. And then this integral. Well, the integral itself should be easy, x squared minus x plus 1 dx. So it's just a bunch of power rule. X squared is increase the power by 1, then flip it, minus increase this power by 1, and then flip it, plus 1 gives you x. Evaluate from 0 to 1. At 1, we have 1/3, 1 to the third power minus 1/2, 1 to the second power plus 1 minus, well, actually it's a 0. Do I really, yeah, let me still write it out. 1/3 times 0 to the third power minus 1/2 times 0 squared plus 0. But again, this whole thing is just a 0. So I'm having 1/3 minus 1/2 plus 1 minus the whole red parentheses gives me 0. I guess I need a common denominator 6. Multiply by 2, multiply by 3, and this becomes 6/6. So 2 minus 3 plus 6, and this gives me -1 plus 6, 5, 6. That is the area of the region. Next question, we are having the region bounded by y equals x squared and y equals 4x minus x squared. Y equals x squared is a parabola open upward. Y equals 4x minus x squared, which is negative x squared, plus 4x will be a parabola open downward. So let's focus on the second one because we all know the first one. It's a very nice parabola open upward with vertex at the origin. How about the other one? Well, there are several ways you can do it, but I will first find where these two graphs meet each other. So you need to find the intersection, which means when both x and y are the same number, that satisfies these two equations. So the intersection will be where the y coordinate are the same and x coordinate are the same. So essentially you are solving what x value makes x squared and 4x minus x squared, which are the y coordinates same. So this, I move this x squared to this side. I have 2x squared equals 4x. So 2x squared minus 4x equals 0 to x. X minus 2 equals 0. So I have 2x equals 0 and x minus 2 equals 0. That's 0 and that's 2. And when x equals 0, this is 0, 0, because it's x squared. And this x squared will be 2 squared, which is 4, 2, 4. Okay, these are the 2 points that the two graphs are meeting each other. So we have 0, 0, 1, 2, 1, 2, 3, 4, 2, 4 here. So my y equals x squared and a parabola open downward. Y equals 4x minus x squared. Honestly, I think this is enough, but if you want a better graph, you might want to say, okay, for our second function, 4x minus x squared, has x-intercepts by setting it 0. So pull out x times 4 minus x equals 0, which tells you the intercepts are 0 and 4. So also you might, I don't think you need to, but if you want to, you can say you can find out the vertex of negative x squared plus 4x. At least the axis of symmetry happens at negative b over 2a. So that will be 4 over negative 2, which is 2. But again, I don't want to write this down because I really don't want you to bother to do all those to get a perfect picture. You just need to know where they meet each other and roughly speaking what the shape is. That's good enough. So same thing here. In this question, you could have chosen x, integral over x, or actually you could integral over y. That's also okay. But apparently, since the two functions are y equals function of x, it will be easier that we do it this way. And in particular, a thin stripe will look like this. Okay, so when x is here, upper, this is x squared, 4x minus x squared, and this is x squared. Then our integral will be in this region that we are talking about. Remember, this is 0, 0, and this is 2, 4. So our x goes from 0 to 2. Then the top, the one on the top, the one function that is on the top is y equals 4x minus x squared. And then the one on the bottom, the function on the bottom is x squared. Then you do integral. 0 to 2, we have 4x minus x squared minus another x squared dx. So this is from 0 to 2, negative 2x squared plus 4x dx. So negative 2 times increase the power by 1, flip it, plus 4 times increase the power by 1, flip it. This is negative 2 thirds x third plus 2x squared evaluated 2 and then 0. At 2, we have negative 2 thirds times 2 to the third power plus 2 times 2 squared. Again, at 0, we have everything 0. That whole thing is 0. So negative 2 thirds times 8 plus 8. That will be negative 16 over 3 plus 8, which will be 24 over 3. And that gives me 8 thirds. Okay, now after seeing these two questions, you can try practice number 1 and number 2. Moving on, the next question, we have y equals x minus 1 and y squared equals 2x plus 6. So here, actually, y is not a function of x in the second equation. Instead, x is a function of y. Okay, so we are going to express everything. We are going to use y as independent variable, but x as dependent variable. The reason is you are not having two functions of x. Okay, this is not a function of x. Y is not a function of x because you have y squared. But on the other hand, you are able to make both of them function of x. The first one, y equals x minus 1, which means x equals, just move your negative 1 on the other side. Y equals y plus 1. And here it will be, move it this way, 2x equals y squared minus 6. And then I divide by 2. X equals 1/2 y squared minus 3. So I do have two functions of y. Then the intersection will be, they agree where they equal each other. So this will be 1/2 y squared minus y minus 4 equals 0, or I multiply everything by 2. I have y squared minus minus 2y minus 8 equals 0. I want the coefficient of my y squared term to be 1. So I can just do, I'm looking for two numbers which multiply to negative 8 but add up to negative 2. So negative 1, positive 2. Y minus 4, y plus 2 equals 0. Y equals 4, y equals negative 2. When y equals 4, x is y plus 1, 5. When y equals negative 2, x is y plus 1, which will be negative 1. So those are the 2 points we are having. We are having negative 1, negative 2, and then we're having 1, 2, 3, 4, 5, 1, 2, 3, 4 here. Now let's look at the two equations that we're having. The first one is x equals y plus 1, or y equals x minus 1. It's a straight line, so you have 2 points on it, just connect them. Next, you have x as 1/2 y squared minus 3. So we are having a parabola open upward. But this time, since x is the dependent variable and y is the independent variable, upward will be the positive direction of x. So here somehow we have a parabola goes upward this way. Okay, although if you know that vertex not supposed to be here, but vertex supposed to be on the x-axis, but it doesn't really matter. It doesn't really matter to our computation. So that's our region, and our region is bounded by y. The lowest y will be the -1, -2, and the highest y will be the 5, 4. So my y, the independent variable, is between -2, is going from -2 here to 4 up there. And the area is, again, these two from the lowest y to the highest y. Lowest y will be the lowest on the y coordinate, and this is the highest on the y coordinate. That's why my lower and upper limits are, well, again, the y coordinate of them, -2 and 4. Now what I'm subtracting are the two functions, this and this. And which x is higher? The one that is on the right is higher. So actually, this is the upper. Y plus 1 is the upper. And then minus 1/2 y squared minus 3. Then dy. This will be -2 to 4, y plus 1 minus 1/2 y squared plus 3 dy. That is -2, 4, -1/2 y squared plus y plus 4, well, dy. Then again, power rule, you just do term by term. -1/2 times 1/3 y to the third power plus 1/2 y squared plus 4y. -2 to 4. So this is -1/6 y third plus 1/2 y squared plus 4y. Sorry, I don't have the room for the limits. Okay, now plug in 4. I'm having -1/6, 4 to the third power plus 1/2 4 squared plus 4y, minus the -2, plugged in, -2 third plus 1/2, -2 squared plus 4, -2. Work them out. This is -64 over 6 plus 1/2 times 16, 8 plus, oh sorry, I don't have 4y, I have 4 times 4, plus 16, minus, I'm having negative and 3 negatives, so the whole thing is positive, or this is -8. So I'm having -1/6 times -8, positive 8/6, plus 1/2 times 4, that's 2, minus 4 times -2 give me -8. So this is -64 over 6 plus 24 minus, well, I can't fit it here. Let's go here. So this is -64 over 6 plus 24 minus 8, 6 minus 6. So -64 over 6 plus 24 minus 8, 6 plus 6. So I'm having these two terms with a common denominator 6. So that is negative 72 over 6 plus 30. Negative 12 plus 30. So you're having 18. Okay, well, sorry, I drew the graph too big and didn't realize I need so much room to work out the integral. But, these are basic calculations. I think you're fine. The key idea is how to set up the integral. Last one, we are having y equals sine x and y equals cosine x and x equals 0. So sine looks like this. I think that's enough. And cosine looks like this. So when you are putting sine and cosine together, you are getting a lot of regions if you only look at sine and cosine. Okay, that's why I'm saying also you have x equals 0, which is the y coordinate. Y-axis. So it's this part. And then again, even with that, you have the left side of it and the right side of it. That's why I'm saying it's in quadrant 1, which means it's here, quadrant 1. Then we are going to look for where they meet each other. So that's where sine x equals cosine x in quadrant 1. When sine x and cosine x are the same, you are here. First of all, this is pi over 2, and this is pi. So you have to have an acute angle, and which acute angle gives you same sine and cosine? Hopefully you know that's 45 degree or pi over 4. If you don't, you can think this way. It's acute angle, right? So opposite over hypotenuse and adjacent over hypotenuse are the same, which means opposite and adjacent have to be the same. So 45 degree. You will need that pi over 4 because on this region you have two functions of x. So you are chopping it. You are doing your integral over x. The lowest x you have is 0. And the highest x you have is this point, which will be pi over 4. So our area will be from 0 to pi over 4. The top function in this shaded part, again this shaded part, is the cosine x. Cosine x minus the one on the bottom is sine x dx. The antiderivative of cosine x is sine x. The antiderivative of sine x is negative cosine x. And then I evaluate. So it's actually sine x plus cosine x evaluated at pi over 4 and 0. So this is sine pi over 4 plus cosine pi over 4 minusing sine 0 plus cosine 0. For pi over 4, radical 2, and 2, you are having opposite over hypotenuse plus adjacent over hypotenuse. For 0, you're having quadrantal angle, 0, no movement, you're here, 1, 0. Minus sine is y, coordinate, on the unit circle, and cosine is x on the unit circle. So I'm really having 2 radical 2 over 2 minus 1, which will be radical 2 minus 1. Now you can try the last practice question number 3.